Good morning, good evening, good afternoon, depending on where you are. Today is March 7th, and this is another of our SIG Apps bi-weekly calls. My name is Maciej, and I'll be your host today. From what I'm looking at our agenda, it's pretty packed, so I'm quickly skimming through announcements. I don't see any topics that we need to share. Probably the most important for all of us is that the code freeze for Kubernetes 1.29 is in the last week of March. Let me quickly go through my notes. It's 29th. So March 29th, that's roughly 3.5 weeks from today. So make sure that all your PRs be reviewed by that date. With that, I think we can jump over to our discussion topics. The first one is SIG Apps annual report for 2021. I've sent an email, I think last Monday, if I remember correctly, to the mailing list announcing the PR. Our report covers the majority of the work that happened in the span of 121 through 123 releases, including all the stable, beta, and alpha features. I hope that I didn't skip any of those since I had to do those manually, although there was discussion that this will be auto-generated next time. I did cover topics such as project health, how many people are contributing to SIG Apps, how many people are present in the SIG Apps meetings on a bi-weekly cadence, how many folks are present in the Slack channel, as well as our sub-projects. Does anyone have any questions, topics, or something that wasn't clear? I remember that Aldo was asking questions about approvers in the controllers. I did answer, but I think I will repeat it here. The question was basically around, are we expecting anyone to be an approver for all the controllers? The answer is no. It's fine, and it's perfectly viable for anyone to become an approver in a single controller or in a group of controllers that he's working most on. So in case of Aldo, he was asking specifically about the batch controllers, so cron job and job controller. Yes, it's perfectly valid to be an approver just for those two controllers. We're not saying that, yes, you have to be an approver for everything or nothing. I think the amount of controllers that we own is pretty broad that it might be harder for us to expect from any single person to grasp all the controllers at once. So, are there any questions? If there are no questions, we are hoping to merge the report as it is sometime today or tomorrow. Okay. The next topic was from, I believe, Abdullah or Aldo. There is a discussion about Kubeflow donating MPI operator to Kubernetes, and there's a link to this discussion. Aldo, Abdullah, do you want to speak about it?
Yes, sorry, I forgot to put my name there.
No worries.
Yes, so we proposed this long time ago in Kubeflow that MPI operator is a common enough. It's a common application that is it goes beyond the scope of Kubeflow, which is AI and ML. So we thought back then that it was useful to have this application, this operator in a different location. And yeah, over the course of the months, this has become like more understood in Kubeflow, and they are now in favor of donating this, or at least some of the folks are in favor of donating the operator to Kubernetes. And the motivation, the technical motivation, is that they are currently working on kind of like a KCM. They are building a single controller, a single manager that hosts all the controllers, and then the MPI operator doesn't really fit. It's a little bit different, and also since this is geared towards AI and ML, if someone that comes from an HPC background wants to contribute, they might get lost in the code base because it has other things they might not care about. So the conclusion was it might be useful to just move it out of Kubeflow, and then Kubeflow depends on it. It just has it as a dependency rather than as a core component. So that's the history of what's been happening here. And of course, if it comes to Kubernetes, the most natural fit is SIG Apps, and obviously not as a main controller, not as a core controller, but it could be done as a sub project. So that's my proposal. I wanted to gather thoughts.
Can you quickly describe what MPI operator does for those folks that might not necessarily be working with Kubeflow, what the purpose is of the MPI operator, and then we can follow up with other questions that people might have.
Yes, the MPI operator simply sets up all that you need to run an MPI application. MPI is a message passing interface, so it's a framework library to build distributed applications that are highly cohesive. So they work together towards computing one single thing. Is that enough?
Yeah, I guess I hope so. Does anyone have any questions about what MPI is? If not, we can jump over to follow up
Maybe
questions.
I can describe a little bit what it does. So in an MPI application, you have a driver and you have workers, and all these workers are indexed by a number. So you need and what you need is a communication channel between all the pods, or all the workers, which would be pods. So for that, we have to set up some services, and then there is more there's more setup that needs to be done, like SSH keys and whatnot. Although there's a different implementation we are thinking of that doesn't require SSH. Yeah, that I hope that clarifies a little bit of what it does.
Can I ask a question?
Yeah, go ahead.
Sorry, this is my first time here. My name is Suraj. So the question I had was, so just correct me if I'm wrong, it's not a question, more of a confirmation. So this is completely new to me. So the way if I'm understanding this right, MPI is the protocol that is used to communicate between the machines, and the machines are kind of doing some sort of, sorry, I don't know much about the distributed algorithms, but something like a MapReduce. And they're basically communicating with each other, and the MPI operator basically facilitates executing that algorithm over distributed machines, except it's Kubernetes pod. Would that be close?
MPI is more like a framework that allows for distributed computation, particularly in the realm of high performance computing. So it does have multiple protocols that are supported under the hood for machine to machine communication. Like low performance, it'll do TCP. High performance, you can get it to do InfiniBand directly. But the idea behind it is that I want to perform this computation. Usually, let's just say it's numerical linear algebra, because those operations are the ones that people really care about in optimizing MPI. So I want to perform this factorization. I'm able to create a program that leverages multiple machines and processes by ID, scatter data across those, do some computation, and then collect the result back. So that's kind of like at a high level what MPI does. And the operator makes it possible to do it on Kubernetes, because traditionally, to set up an MPI cluster, you would literally be installing the MPI daemon, one of the MPI daemons like MPIC or something else, across all the machines inside of the cluster, and then allowing the controller to kind of timeshare the resources on those machines across individual programs, which is very difficult to do inside of Kubernetes land, because there is no notion of like a machine, right? Like the resources that you acquire are acquired via scheduling containers and pods, and the pods are ephemeral. Whereas in old school MPI world, like a machine was something you racked and stacked.
Okay. Can you just say that last two words again? I'm really sorry, I missed you there.
A machine was something you racked and stacked. It was a physical SKU that you had to purchase, plug in, provision, and add to the cluster. And then it lived out its lifetime until you decommissioned it or it broke. Whereas with Kubernetes, resources are ephemeral, and not only are they ephemeral, they're elastic, which presents some challenges in how you would take a traditional MPI type scheduling problem and, you know, make it work inside of a Kubernetes cluster.
Got it. And so this MPI is when you say framework, is it like a framework which has a code implementation, or is it more like a conceptual framework?
There's some specifications, it has multiple implementations, and from a programming perspective, you write like a C or C++ or another language program. My experience is C or C++ using the MPI primitives, and the software, the libraries that you're using help you distribute your compute under the hood.
I see.
You could think of it like in more, if you're familiar with like CUDA or any of the things that you would use for GPUs, or OpenMP, which is like a multi-threading framework. MPI is like that, except for parallel processing across multiple computers.
Okay, I think I've got some reading to do, but thank you for the explanation. Thank you for the pointers.
So Alda, I had a question, I think, which is rooted in the issue that you pointed in the notes, how the current implementation of the MPI operator looks like, how much of it is to be made generic enough to be moved over to the Kubernetes SIG org, because I assume that currently, as it is, it's tightly coupled with Kubeflow. So how much effort would it be required to make it less tied to Kubeflow, but rather generic, so that we can easily move it over?
Actually, it is not tightly coupled. There is no cross dependencies for once. And there is no API fields that refer specifically to other Kubeflow features. It always was kind of decoupled already. The only thing, of course, the Kubeflow project defined a kind of set of common APIs, kind of like the meta APIs that we have in Kubernetes, and all the projects inherit those. But they're just APIs. They are just field names, just to have them common, but they don't dictate any behavior. So just duplicating that code would be good enough, and perhaps doing some cleanups because they didn't really adhere to the API guidelines that we have in Kubernetes. And yeah, minor things like that.
Okay, I assume you and Abdullah will be working on this topic.
Hi.
Actually, no. We might in the future, but for now, Carlos here that is in the call, he has a high interest on the project.
Mhm.
I'm willing to do the migration.
Okay.
Hi, Carlos. Anything you want to add, Carlos?
Yeah, but
Don't.
Oh, okay.
Okay.
Carlos said his mic is not working. I can barely hear him. I was about to say to bump his volume a little bit higher.
Now?
Yeah,
Yes.
much better.
Okay, yeah. I've been working on that portion of what that Aldo just described, the API. And yes, so the common, so under Kubeflow, there is a GitHub project that is called common, and the MPI operator inherits that. But if you really go and see it, it's a kind of like a wrapper around stateful sets, jobs that insert some metadata for Kubeflow. So duplicating that inside the MPI operator itself wouldn't be much of a leg up work, and will really help the project itself for a cube builder and using the controller generator. So it's really good for the project itself because I was trying to get the controller, the cube builder to auto set some defaults. And it's really hard when you are importing an API, and that is even good for the project. And I will be working with Aldo on that if we get the approval to donate it.
Ken, do you have any questions?
So my only thing was mainly the idea is you want to donate this so that people don't keep re-implementing them, and we have like kind of a uniform solution that's the community supported version that everyone can leverage and build upon. And I get that aim. Maintainership is my only concern. Like, would it be the current maintainers who would continue to contribute and maintain the project?
Sorry. Yes. In terms of feature development, at the moment there is not much going on. Although there might be, Carlos is working on PMX, PMIX, which is a protocol to do communication between the workers. Sorry, the driver and the worker. So I guess what I'm trying to say is I don't expect a huge maintenance burden, but I am willing to maintain, to review, and all those kind of things. And I'm pretty sure Carlos will be able to do that as well.
Yes,
Sounds good. Thanks.
I volunteer as helping Aldo, and there is a growing interest from the OpenMPI community, so in the academic community, in having MPI set on top of Kubernetes. So I can only guess that we will get help from OpenMPI contributors themselves. That's a good thing. And as Aldo said, a milestone they have for 2 or 3 years down the road is called PMIX. So not MPI, but PMIX. Yeah, the same letters, but in a different order. And it's kind of like a next version of the core itself of what we will call MPI. And I'm already working with them, and the proof of concept are working, and they are interested in that to the point that they are writing SIG code internally on the MPI project to be Kubernetes aware. So the MPI community is really interested in Kubernetes. So that's a good thing.
Are there plans to migrate to the job API? Is that part of your roadmap?
Because that's a question for me. Not yet. I think the major problem, the major limitation is that the workers don't really work to completion, right? They are more like servers. So it kind of behaves more like a stateful set in that sense. So, but I guess the discussion is open to decide what to do. What's the best lower level workload API that we can use long term? Because currently the MPI operator is creating robots, which is might be problematic. I don't know if Carlos has thought about it in another way.
Yeah, for sure. But making the case on maintaining the project, I will be there and I will be driving the community into bringing more contributors to it as well. That's one of the things I'm committing to.
Okay, that sounds reasonable to us, I guess.
I have a slightly related question.
Yeah, go ahead.
Yeah, so Aldo or Abdullah, do you see that the direction that you are thinking of at this point of time is to bring MPI under the Kube batch working group? Is that what you are thinking in the long term?
Certainly, it falls within the scope of the things that the working group batch will be looking at. But I guess that's not a very pressing question at the moment. Most important is how it would fit in SIG Apps today.
An important thing is that work groups, per their definition, do not own any piece of code per se. There are more, until we solve a particular problem and they are being dissolved and the actual work is happening within the SIGs. So for this particular bit being a sort of controller, it seems natural to fit more under the SIG apps rather than the other two SIGs that are part of or are sponsoring the work group batch work group.
No, I completely agree, but I'm thinking more in terms of what is the end goal here? Like we want to, because some of the goals that we had set for the working group is to improve the workload API, identify the gaps in that. So I'm wondering if this is started as part of that effort, or you think this is as a separate effort. The other question that I have is, like at this point of time, apart from the Kubeflow project, is there any other project that is using this, or is there any interest that this will be used in future, so that we can arrive at consensus that yes, this is the pattern that, or this is the library that we want to agree upon?
Well, not the library, but yeah, MPI, as with Kubernetes and open source project, it has many implementations. So there is the open MPI that is kind of the standard, but you will find Intel MPI. There is a Cray MPI. There are many implementations. So the MPI operator under Kubernetes 6 should serve as a generic implementation that if these other companies wish to provide Kubernetes support, they can contribute and add their specific needs for their libraries. But the basic of distributing pods and connecting the pods, like the very basics of the MPI implementation, should be the focus of the MPI operator. And users, aside of Kubeflow, Yeah, I can provide a list of companies using already the MPI operator. So far, it's just like on the proof of concept level, because as you can even see, the project is kind of on a beta, like pre-beta alpha kind of a stage. So, but companies like NVIDIA, Red Hat itself, I work for Red Hat, Intel, I have friends there, and they are already running some internal proof of concepts with the MPI operator. So that's why I think there's a big interest on upstream contributing companies to have this under SIG, because they are planning on having future products that will be based on the MPI operator.
Got it. So there are two pieces here. One is the generic API, the other is various implementations that can be done by various companies. But at this point of time, you think that MPI operator is perhaps going to be the implementation that most of the companies would conform to, or vendors would conform to. Am I right in summarizing it?
Yeah, for sure.
Okay. Okay, that makes sense. That's all I have.
Yeah, with MPI, the difference on the implementations mostly go on the hardware side of things, right? If you're buying a networking interface from this vendor or the other vendor. So that's when the differences kind of come into place. But the standard overall, when you're writing C code or Fortran code to do MPI is the same. The difference is going into the compiler mostly.
Okay, as part of the repo, you're going to have both the API and a sample operator, a sample MPI operator.
Yeah.
Okay.
Sorry, maybe you're getting confused. MPI is already standard. I'm so sorry. I need to take a call. It's not that important what I was going to say.
MPI is a standard, and there are multiple vendor implementations. Popular ones are like OpenMPI, MPIC. There are proprietary implementations and stuff, but you wouldn't necessarily need to include that here. Based on, from what I've seen inside of the architecture, what exists, you could use a different MPI implementation in terms of the libraries and so forth by providing a different container to implement it, and then you're fine. Like the operator is vendor agnostic with respect to the implementation of MPI that's used inside the cluster.
Yeah,
right, like you can think of it as you basically compile your application with the MPI library, and this application becomes your container, and then the MPI operator would deploy this container for you so that they can communicate with each other, like in the various different instances of like the workers. So when you launch the operator, you say, I want 10 workers. It will basically place 10 instances of this binary running on in pods on 10 different nodes. And it's just like basically launching it using MPI start, which basically SSHs to the nodes. If we are in a non-Kubernetes environment, it SSHs to the nodes and runs the binary, and that's it.
Got it. I'm a bit confused about the API part there. That's why I use that term. So are we going to have a CRD or something which says these are the number of workers in Kubernetes which actually represent the workload? Or you think it already exists in the existing workload?
Yeah, so that's the MPI operator. So the MPI, yeah, that's the MPI operator. So the MPI operator is a CRD and the controller that basically reconciles the CRD. So you describe your job, like it's called the PI job, right, saying that this is the container, I want this number of workers, and this is the driver. And then the controller basically creates the pods that represent the workers and makes sure that they are able to communicate with each other and whatnot.
Yeah, so to provide more background there, when you are going to deploy an MPI application, and the good thing is the hello world is host name, so every Linux machine has host name. You need to provide two things to the MPI binary in the launch host, right? You provide a host file that the MPI operator controller is doing that for you and injects that in a config map, but let's not get there. And you will also pass to the MPI binary how many ranks. So in the MPI ecosystem is called ranks. For Kubernetes, it would be more like pods. So how many pods are you going to run for this specific application? So you pass two flags, the end of the ranks and the flag for the host file. So the host file will kind of provide the IPs or the using Kubernetes, we can use DNS. So it would provide the host list and how many ranks or processes you want to run. For Kubernetes, this gets translated into how many pods do you want to run. So that is what the MPI operator is doing. It is providing that list of DNS names. So it will run X number of pods, and then it will communicate with Kubernetes and create a list and inject that list as a config map. And you as a user, you must know how many ranks you will run. And on the CRD of the MP operator, you define, oh, do it with 10, with 20.
Yeah, I understood that part. I think what I was asking more about is the CRT going to be generic enough to be used by all the MPI use cases, or it doesn't matter at this point of time?
Oh, no, that's what Abdullah was explaining. What really changes is how do you compile your container. But the CRD and what the MPI operator is providing to the user is generic enough in such a way that it doesn't matter with which compiler you put inside your container, it will work, because what you need is the kind of the scaffolding that the MPI operator is providing to you, right? Like running the stateful sets, creating the config map with the host list, like this scaffolding that the MPI operator is creating for you is needed regardless on if you are compiling this with Intel, MPish, or whatever. So it's generic.
Okay.
Okay, I'm hearing no other questions. So I guess the overall sentiment is that we are fine with sponsoring this project to be one of our sub projects. Okay, and that's the case, we can move over to the next topic. Ryan, conformance testing.
Good morning. Yes, we have two topics. The one is, I can talk to that. This test has been created by Stephen. He's the creator of it. It's been sitting for a while. We would just like some eyes on it because test freeze and code freeze is approaching, and we really like to get it on the test grid to run these 2 weeks so we can merge it in as part of conformance before the end of this release. So we appreciate some eyes on them. We believe it's good to go.
My general question when I was talking last time with Ken is, can you roughly estimate how many of the apps APIs is currently covered by conformance? I remember when we spoke last time, we're roughly most of them, but I can't remember.
Yes, give me a moment. I'm going to share with you quickly a link.
Mm-hmm.
So in the group apps, we have basically only controller revision left. If you have a look here, where's the chat? I'll share this link here. So there's API snip and what's left for apps. So basically only group. So we really took a hard swing at it a few releases back to try and cover everything except the controller revision, but that's the next topic that we'll discuss. We have some questions. Steven's done a lot of work on controller revision. He just needs some clarification on some things related to controller revision. Then things like the PR that we present today is part of job. Yeah. So not everything is under app. So this fall under stable bash. So this would also, if we get this to merge, we will cover just about all of the.
Okay.
There is another job test that we're busy working on that will cover the rest of the job. So we're really trying hard to, and also if you look at, let me zoom out, I'll take you there. Moment. If you look at this, you would notice that we are basically only 51 endpoints left. But unfortunately, the most difficult ones got left behind. That's the way it is. If you leave the cookie jar open, everybody takes the nice cookies first, and the ones nobody wants stays behind. So yeah, that clearly shows you what's left behind, and we're busy hacking at those very hard. The idea is to get all this done before KubeCon North America. That would be a great celebration if we can get that sorted.
Okay.
If there's any volunteers that want to help, send them our way. But we found that everybody's got other things to look at. So that's why we're washing the dishes here. And Stephen is our champion on that.
I'll definitely try to find some time this week to get this one, especially the batch bits, since this looks pretty small and I did review them in the past, so that shouldn't be a big problem. For controller revision, when you have them ready, just ping me and I'll try to carve out some time.
I'll have to swing over to Stephen. We have questions on it because it's a bit of a sticky one for us. So Stephen, you can take over that discussion.
The main issue around controller revision is just I've already found and already gone through some of the stuff where there's an example of daemon set driving controller revision behind the scenes, but I've trying to look at I've got some notes a little bit further down that link off to a document where I've been doing some research for this particular set of endpoints, and I'm having some issues around the what's actually happening with the create process, and actually there's some issues around dealing with real history versus fake history, which is what's been done in the integration tests, and just wanting someone to point me to blog post / code, give me a tip or two to do with the controller revision, so I can just make a little bit more progress so that I can get closer to a running test for someone to finally approve. It just seems everyone's got documentation about the standard resources, but controller revision seems to be left behind, because I found when you do a kubectl explain, there are still references that says that it's a beta actual resource and it's still going to have changes made to it. So it seems to have not had as much love as the other resources in SIG Apps.
Ken, do you know the story behind controller revisions? I don't recall being part of the work around controller revisions. So
in the same way that replica set kind of is a way that you can roll back a deployment, right? Like you keep a reference to the object around, and it allows you to kind of detect if like the prior revision was at the declared state right now. So like if the images match, so forth and so on, it'll just roll back or scale up the existing replica set. The same thing is true for controller revision. It's just an intermediate that stateful set and daemon set use to save their state.
I found the controller, there's a history controller that controller revisions interacting, but I've sort of like lost the thread of where the code base is running to find out actually who's really driving the controller revision creation process behind the scenes. So I know where's all the tripwires when I try to do patching and replace. Because eventually, if there's any flakes or anything like this that come up when we go through our 2 weeks before we promote, I generally end up having to deal with some of the other people like Clayton, or potentially some of the other people in SIG architecture that some like poke in on some of the flakes occasionally. I want to have it so that it's reasonably bulletproof before it goes to conformance. But definitely up for any help possible. It's like bet me at the moment.
Well, I mean, the thing is, it's basically used in rollbacks and rolling updates, right? So, I mean, the coverage of the actual utilization and how controllers would use the API surface is pretty good given the conformance testing that we have around rolling updates right now. The endpoints that I mean, so yeah, we would never use replace. We would never use lists for all namespaces. Delete should actually be used. And create is definitely used.
Yeah.
So how are we saying that these are that these are untested? Why are they coming up as untested? I would even think that given the test that we've labeled as conformance, that we should be exercising these endpoints.
It's most likely that we are. The majority of the API specifically, the API testing that Ryan and folks were working on, they were adding just the ones that are verifying all the endpoints. So especially those endpoints that you mentioned that are not being used, by the fact that we are exposing those, so listing all namespaces or deleting all namespaces, if I remember correctly, or replacing, we expose that API, even though it's not being used and probably historically should have never been used. The fact that it's out there, we are missing those tests. And by how we are testing those, we just have, a single test that just iterates over all the endpoints to ensure that they are covered,
so
not as part of something.
Well, I guess that was my question though, right? So my understanding was that if I mark a test as conformance, the API snoop was capable of detecting that the API was utilized based on the API calls during the conformance test, or is that not true?
That should be true if it actually does exercise, if there's a conformance test and it does exercise the API snoop would pick it up. So if you do have tests that you are convinced are actually supposed to hit these,
it's create apps v1 namespace controller revision. Okay.
Correct.
That's
there's a lot of tests. A lot of the endpoints are covered already with integration tests, but they're not being exercised through a actual conformance test. That's
so,
yeah.
So what I'm saying is, like, with a stateful set, if you're testing rolling update or you're just testing creating it, a controller revision would be created. It should be a namespace controller revision would be created as part of that conformance test. And I have to go look at the exact conformance markings. But as the last time I checked, the conformance for stateful set did have stateful set creation and so forth as part of conformance. So the API call, some of these API calls for controller revision, I would think should be getting picked up. But if it's saying it's not, let me take a look at that. I mean, like
controller revision, all the other resources in apps is actually, you're right, they're all tested. It's only the namespace controller revision that's not being seen by API snoop. And it could be that there is actual test, but that we haven't found. So that would be also good. And that there's a reason that it doesn't pick it up, but we'll appreciate some eyes.
Okay.
It's probably the way that generally the conformance tests around like stateful sets and daemon sets seems to be the one that the controller revision integration tests are using predominantly at the moment. And generally in those conformance tests, generally it's a case of we're just replacing directly the daemon set, which doesn't take it through like doing a roll rollback. And I think there was an earlier initial test that's in there, but because it hasn't been promoted to conformance, we don't track it then. So it's, and some of the original integration tests around that do exercise controller revision are using what's called fake history, where I believe it should be dealing with like real history objects. From the way I believe all the conformance endpoint stuff is dealing with real information.
Did you have a proposal of what you wanted to do? Did we just want to run, like, so did you just want to write some API testing that runs through creating an arbitrary controller revision for the purposes of exercising the endpoint? Or is the purpose to like contextually test it inside of the controllers to make sure that they're using it the way it's supposed to be?
The general idea is that each particular SIG that we work with ends up basically just validating that we're exercising the resources the way it should be used. So if there's something like for the job status one where something's not been exercised completely correctly, then give us some feedback and we'll update the test. I went through it about 2 or 3 minor revisions when I did some stuff with pod templates the last week, I think it was. So I'm just looking for guidance on how best or where there's extra resources to deal with controller revision at this stage.
So it is in the hands of the SIG to decide what is acceptable for conformance. It does go to the conformance group, and John Barameric and Clayton and those folks have to decide whether it's allowed in for conformance. So there's a further review, but the SIG is normally the authority that makes the decision. And we really like to help you finish off this apps endpoints as soon as possible.
Generally with the SIG App endpoints, we don't generally run into too many issues where potentially an endpoint has to be tested. We have to make sure conformance tests are, of course, testing just the API, and we've got to make sure that everything's good for if it needs to be run on any other platform, whether or not it's Windows, S390s, sorry, other OSs that come up for conformance from time to time.
Another scenario that does happen, and you said that your place and list should probably not even be available. What we do with endpoints that is, like Stephen just said, vendor specific or is related to storage, or there's criteria for making that endpoints are qualifying for conformance. So if they are disqualified for any reason and you make the decision in this SIG that for this reason it's disqualified, then we can make it ineligible. Then it comes off the list and it goes on the back burner for later review. So that's also a possibility. But then there need to be valid reasons why it should not be conformance eligible, like an optional feature. Or...
I understand. I kind of understand that perspective. I mean, like on one hand, so the difficulty is kind of like this, right? Like when you implement a Kubernetes API style resource, the resource is a built-in resource. By default, there are a certain set of operations that you're going to just enable by declaring that resource inside of the tree, right? So we get a lot more than we actually use. The actual utilization of the resource, my opinion, is really covered by the existing tests that we have today. Like looking at the conformance tests that we have for the workload controllers, we are actually like, the fact that you can run that test implies the existence of the resource and implies that the controller can exercise it in the way that it needs to. The API surface for controller revision as used by the workload controllers hasn't changed in years, right? Like it's not something that's in flux or in flight on a regular basis. It's super stable. So the other APIs we expose, we're probably never going to use them. Now, the kind of downside to just saying, okay, well, we expose them, so let's go build tests for them and make them part of conformance, is that now we have APIs that we're not actually internally using that we're committed to supporting indefinitely as part of conformance, right? And that's kind of the thing where I'm like, is this really a value add? Like we're gonna put code in that we own and commit to supporting a bunch of APIs that really the controllers don't use. I guess like, and like my intuition, which I don't actually have evidence in this domain, is that they're not going to be valuable for other people who are writing controllers on top of this API, right? Like if it was like, we don't use them, but I could see some value add to ensuring conformance so we can provide them as a utility to the ecosystem, I would be like, all right, let's just go test them anyway. So I mean, that's kind of the struggle, right? Like adding the conformance here isn't going to be a value add for the built-in controllers. It's probably not going to be a value add for other people who are writing controllers. And it's going to be code that we have to own on top of a promise to the community that we're committed to at a V1 level fairly indefinitely. That being said, like because they're basically not utilized, I don't think that outcome is horrible. It's just seems suboptimal to me.
And from the last discussions about deprecation of APIs, from what I understood, is there's a decision that they would likely never deprecate anything that's in production. That's already maybe not maintenance won't be done on it anymore. So if it does go away, so from that point of view, it might be useful for us to write the test. That is what we're doing. So if we get the right help, we can make it.
I mean, it's
Jack,
not
what are
about,
your thoughts? Oh, sorry.
yeah, I think what Ken was trying to say is that we're probably not going to deprecate the APIs or remove it for that matter, but it's about not covering them with conformance testing if we are certain at this point in time that they're not being used and most likely will not be used. So you did mention an escape hatch of, well, we will just say that they are not covered by conformance. And I would do just that for those few that are not being exercised. And we can return to this particular decision in the next round of reviews. But for now, if we are certain, and from what Ken is saying, we are, then I'm perfectly fine with making exception for those few for the time being. And we can revisit that decision during the next round of reviews.
So do you want to make them, if I understand, do you want to make them ineligible for conformance?
Yes.
Would that be only list and replace, or would it be the whole set of?
No, I would try to nail down those that are not currently covered by the existing conformance tests that are being run against daemon sets and stateful sets. If you can nail down, then I think you mentioned listing all namespaces and replace. If those are the only two, then I think I'm fine with marking those two as not eligible. those seem reasonable.
I can
All
I
right.
can look at doing a run through all the current conformance tests for both daemon set and stateful set and show all the endpoints that those tests are actually hitting and making sure that there's a clear story of, is there actually any controller revision endpoints being hit at all as part of the current process? And then we can then look at doing some feedback and getting some more clarity on which ones you want to potentially make ineligible versus understanding what is the current test running and do they actually force a controller revision action as part of the current test run, or whether or not they need to look at doing some action of either doing a rolling a roll up or a roll back that would then force the controller revision actions.
Yeah, that sounds reasonable. If you could, you know, when you have that report ready, ping myself and Ken on the SIG Apps Slack or in the mailing list, and we can revisit and we will say yes, no. But all the evidence shows that it should be just those two, most likely. If we will notice or we will learn that we are missing something else, it's possible that I would prefer, it's possible that we should probably promote one of the existing, because most of the, I was quickly skimming through the daemon sets test as well when Ken was discussing, and I'm considering promoting some of the pre-existing daemon sets or stateful set tests, which might be touching the necessary endpoints to ensure that we have the required coverage.
If IPI actually does pick up test that is touched by E2E test but not conformance, and let's have a look at a list. Moment. Actually, not one of them are touched by an E2E test.
Okay.
I think, Ryan, there was an issue where because the daemon set tests, because they're run serially, they're not picked up by Snoop until they're made conformant tested. I think there was an issue that we found historically. But
okay, so from your side, if there's an E2E test that you want to make conformant, that would also help us and pick up and see what would pick up. So if we promote those.
Yeah, that's definitely a preferred option, because that clearly shows that there is a gap in our testing that we should improve, rather than pushing just the API bits testing.
Cool.
Okay. Okay, cool. We're
you.
at top of the hour. We run over by a minute, so not that bad. Thank you very much, all. Enjoy the rest of your day. Take care. Bye.
Thank you.
Thank you.